Bismillahirrahmanirrahim. Okay. Assalamualaikum, madam. Today, me and my group mates gonna present our assignment one project that is the smart circuit monitoring system using IoT. Okay, before we start talking about the project, let me introduce myself and my group members. Muhammad Haziq bin Roslan, ID number 52231247445 is our leader. Myself, Muhammad Zaid Aiman bin Zulkifli, ID 522231248813. And our last group member is Muhammad Zamzam bin Zulkifli. ID number 522231246664. Okay. In this slide presentation, it will be separated into 7 chapters. That is the introduction, background literature review, system design, implementation, result analysis, challenges and solution, and lastly conclusion. Okay, for the first chapter is the introduction. Brief overview of the project. The smart circuit monitoring system designed to monitor electrical parameters such as voltage and current in real time. It combines traditional electrical circuits with modern networking technologies to create a low-cost, intelligent solution for observing circuit behavior. It was achieved by using sensor connected to an ESP32 microcontroller. The system collects data and transmits it through communication protocol MQ telemetry transport or aka MQTT. The data is then visualized on a live dashboard, allowing user to monitor the circuit remotely and effectively. For this assignment, there are 3 objectives. Those are to design a basic electrical circuit integrated with voltage and current sensor. Second objective, enable data transmission using network protocols such as MQTT. And the last objective is to visualize live data on a web dashboard to support remote monitoring and analysis. Okay, for our second chapter, background and literature review. Basic concept of electrical circuits. Electrical circuits refer to closed loop through which electrical circuit flows. These circuits are the foundation of electrical system for this project. According to Ohm's law, the relationship between voltage, current, and resistance is given by the formula V equals to IR. Understanding this relationship is crucial for accurately measuring and analyzing electrical parameters in real time. Why is this integration important? Integrating electrical circuit with networking systems such as IoT and automation is important because it brings the intelligent efficiency and accessibility to modern electrical system. This allows for real-time monitoring of voltage, current, and power, enabling early detection of fault, overload, or abnormal usage. Remote access to mobile apps or web dashboard make it possible to control and monitoring system for anywhere, which is highly useful in smart home and industrial settings. Additionally, this integration promotes energy efficiency by helping users track and optimize their power consumption. Uh, for this project, there are 3 related technologies. uh, and each of them play their important roles. Those technologies are MATLAB, Simulink, Arduino, and ThinkSpeak, Blink, and Node-RED. For system design, I will pass the mic to Muhammad Aziz. Thank you.
Okay, I will explain for design. Basically, first most we describe of the electrical circuit first. So basically use like plumb as a load and connection to power socket that supply AC voltage. The main component are mounted on a custom PCB and include an ESP32 microcontroller and ZMT101B voltage sensor and ASC S712 current sensor. Uh, the ZMT 101B is connected by parallel, which the load to measure the AC voltage, while the AC 712 is placed in series to measure the current flowing through the pump. The sensor and send the analog signal to ASP32, which is process the data and display the real-time value on the connect LCD screen. So the SP32 also send this data wirelessly to mobile dashboard, and a digital multimeter in is used analog side the system for calibration and compression, showing voltage of 248 volt, which is matching in the sensor reading. So next slide, please. So for the network system, what is network system basically? So the networking system is a smart circuit monitoring system ensure the real-time data collected from electrical parameter is transmission efficient to user interface for monitoring and analysis. For the data flow, uh, which is I will show next. The voltage and the current sensor are connect to SP32 microcontroller, which is also provide the Wi-Fi connector. The SP to read the analog value and process the data, then transmission it cloud server or web dashboard over the internet. So for communication protocol, the system use MQTT, which is message queue telemeter transport and a lightweight and efficient message protocol, ideal for IoT application and ensure fast and reliable communication between ESP32 and cloud platform. Which is next slide. So this is our data flow. Basically, uh, we have one is sensing layer and second processing layer and third one is network layer and lastly application layer. So next slide, please. Okay. For system architecture, for block diagram, which is I will show next for flow block diagram, but I will explain this first. The sensors block is connect to microcontroller, which is connect to Wi-Fi model and connect to MQTT broker. The broker is connect to dashboard. And next slide. So this is the flow of block diagram. So basically just a simple flow, the sensor, microcontroller, Wi-Fi model, and dashboard. So I will explain more for the next slide about next slide please. So I will explain more about sensor, microcontrol, and Wi-Fi module and dashboard and so on. Okay, so basically sensor role dia role is which is role for sensor block is collect real world data, which is temperature, humidity, mention, light and pressure. So how it work? Actually sensor convert to physical parameter into electrical signal, which is analog or digital. For example lah, DHT L11 temperature is humidity and PIR and LDR. LDR which is light lah, and PIR is mentioned motion. So communication is interface which is microcontrol via protocol like uh 12C SPI and UART and other pins. So we move on to microcontrol, which is MCU, aka MCU, and the role is process sensor data and act as the system brain. So how it work? So basically read a raw data from the sensor and process data, format the data for transmission and control the Wi-Fi module to send data to cloud. For example, I do know Uno and then ESP32 and Raspberry Pico. Next slide please. So for Wi-Fi module, which is role model dia enable to internet connection for microcontroller. How it work? Connect to local data Wi-Fi network, transmission data to data MQTT broker, and all over internet. retrieve the command from the cloud. So for MQTT broker pula, the role is manage communication between device, which is sensor, and application, which is dashboard. So how it work? Use the publish subscribe models, so which is sensor publish data, and dashboard subscribe to topic to retrieve update. So the topic to example topic is home sensor and temperature, which is acting as a center of message router. For example, open source broker, which is Mosquito EMQX, and cloud broker, which is AWS IoT Core, and high MQ cloud, and Q feature is like white protocol and support QoS level 0 0 1 2 for messages relatable lah. For next slide please. Lastly is dashboard. So basically the role dashboard is display real time data, allow user interaction. So how it work? Subscribe to MQT topic to retrieve sensor data, visual data using graph, gauge, and alert. Man send command back to the device, and for example web based dashboard, you build Thingbot and custom solution Python JavaScript apps with MQT library. So next slide please. So here I will explain about step by step as explanation how to circuit was simulation or build. So um there are three main component, which is ASC712 current sensor and ZMT101B, which is voltage sensor, and ASP32 microcontrol. So first we go to first step, which is component placement. So which is component placement, which is a start by placing of all component on the board or PCB. This include ESP32 board, voltage sensor, and current sensor, which such as CT sensor or ESC712. And you will ensure that sensor pin, which is VCC and GND, and the signal are clearly labeled and accept, accept, accessible for wiring to SP32. So the power supply, which is and next is power supply. Provide a stable power supply for ESP32, usual 5 volt via USB or regular power source, and ensure that sensor are power correctly, and typical 3.3 volt or 5 volt. Depend on specific incorrect voltage can damage. Depends on specific. And for information is incorrect voltage can damage the component or cause incorrect readings. Uh, the third one is signal connection, which is connect the signal output from the voltage sensor to GPIO 335 and current sensor GPIO 34 on the ESP32. These are ADC, which is aka analog to digital conversion input, which is convert the analog voltage to digital value processing. Also connect the command ground between ESP32 and sensor to ensure the stable operation. So for one is interior testing, which is upload to provide Arduino code to ESP32, and open sys monitor in Arduino ID Arduino to check where Wi-Fi connector successful and verified the analog value and being read from the sensor. So the number five, collaborate calibration calibration adjust which is adjust the conversation adjust the conversions of formula in the code based on the specific sensor used. For example, if we using ASC 712 for mapping raw ADC value to real world current value using the sensor sensitivity. So the last one is safety measure. So for safety measure, of course, when we measure when sorry, when we measure the AC, which is the voltage or the current, uses isolate sensor to avoid direct contact with high voltage line. Oh, oh, okay. Then they these all step that lead to successful operation of smart circuit monitoring system. So the next slide, please. So here the mapping from the mapping for our sensor Arduino and like Madam see right now, which is the real project. Uh, it it how it work. So next slide, please. So for the I will explain for the code. So basically, ESP32 based on power monitoring system connect to Wi-Fi using predefined connector, read to analog voltage which is GPU 035 and current GPU 034 sensor value via 12-bit ADC scale to O to 0.3 volt, which is package the team I package them into the time span JSON payload which is with my list and publish to MQTT broker which is that is the code IoT slash circuit slash data for every 2 seconds using no blocking delay while maintaining the connection via reconnect MQTT. And then but like sensor calibration and electrical installation and real world unique conversion. So next slide please. For the next slide I will pass to Zanzan for result and analysis.
Hey, good evening, madam, and I will continue the presentation from here. I'm Muhammad Zamzam Zulkifli. We'll go for the first presentation for the results and analysis. As you can see, here are the results which is we get. Uh, First is voltage versus time that showed a stable readings around expected AC level. And the second graph is current versus time, which is fluctuated slightly with varying loads. And the third graph is power versus time. The power is calculated using V times I versus time. It is demonstrated predictable patterns matching the circuit usage. So this show the system work as intended. And next slide. Here is the data tables and log, which is this is will be our dashboard. So this how the dashboard will looks like. There is a timestamp, voltage calculated from the circuit, the current and the power. So the and for the analysis of circuit behavior and network performance. The circuit behavior is normal loads produce expected voltage and current trends. Under stress, temporary spikes were observed for the network performance. The MQTT protocol provided consistent transmission with minimal latency. There is no significant data loss occurred. Our data logs confirm that reliable performance and fast data transfer via MQTT, which is forever. There is a fault detection or anomaly identification, which is we put in the system, and there is an anomaly detection was performed manually by reviewing the visualized data logs. A voltage surge reaching 240 volt was identified and highlighted on the dashboard as an unusual reading, and it did not include automatic response mechanisms such as shutdown protocols or real-time alert notifications. Although our dashboard captured a voltage spike up to 200 to 244 volts, it's important to note that this was identified during manual review of the data logs. Unfortunately, we did not include a screenshot or mark graph of this spike in the slide, but it was visible during the live testing. So for now, we can see there is a voltage on data logs. Okay, next. For the challenges and the solution of this project, there are a few that we face, and so I will explain about it on the challenge phase and how we overcome it. One major issue was a sensor noise, which led to inconsistent readings. We overcome it by implementing a signal averaging techniques in the code to smooth out fluctuations. The second challenge is the involving Wi-Fi connectivity, where there were unstable network conditions, which is we overcome it by incorporating a reconnect logic that automatically restores the MQTT connection if it drops. And the last challenges we're going to talk is about the dashboard refresh rate, which is initially caused delays in the data updates. We can overcome it by doing adjustment on the MQTT quality of service QoS settings, when resulting in more consistent and timely data visualization. In the future, okay, sorry. Next slide, loh. Okay, there is also a possible future improvement that we hope to implement on this project, which is what we can think of right now. If future enhancement could include adding automatic alert systems such as SMS or email notification to the user devices, mobile devices like handphone or PC, to promptly warn users of any faults. Implementing anomaly detection algorithms will improve the system ability to predict and respond irregularities. So by adding this algorithm, we hope that it make the system smarter and more responsive. Next. Next slide. Yeah. Okay, for the conclusion. In summary, the key achievement of this project include the successful design and implementation of a smart circuit monitoring system using an IoT technology. The system was able to accurately measure voltage and current in real time using few sensors, which is connected to the ESP32 microcontroller. It has successfully transmitted data using MQTT protocol and visualized it on a live fed dashboard. So this project has demonstrated the effective integration of the hardware and software components, enabling a reliable remote monitoring of electrical parameters. Overall, it has achieved its goal of creating functional, low-cost, and intelligent monitoring system, and it is suitable for the educational and practical use. Okay, next. Oh, sorry. Sorry. I forgot to explain about the key takeaways for this project. This project is important because it is demonstrate how traditional electrical systems can be enhanced with IoT technology to become smarter, safer, and more accessible. This was done by integrating a real-time monitoring, remote data transmission, and live visualization. The system provides a practical solution for detecting faults, managing energy usage and improving electrical safety. This MQT and the live dashboard demonstrating on how traditional system can be upgraded with modern technology for better safety and efficiency. Okay, next. For real. Alright, that's all for our project presentation. So thank you for listening, madam, and we are happy to answer any of your questions. Thank you, madam.